Here we have graph transformations and a topic very, very important, okay? Students often feel like, yeah, I've got this, okay, and they're easily forgotten, all right? So let's get straight into it. The first transformation we've got to know is translation, okay? And this is one that I forgot in my GCSEs, okay? I was too busy trying to flip it, transform it, teleport it to another dimension. I forgot about this simple translation. Okay, and if you don't know what that is, that's fine, let me explain. All right, so if you've got the triangle ABC and we want to translate it to A dash, B dash, C dash, this triangle here, okay, as you can see, the triangles are in the same orientation, right? You can literally pick this triangle up, don't need to rotate it, put it down there, okay? And it's the same. As you can see, these other ones, they're rotating round. They don't have that same property. Okay, so when you see this, you should scream translation. Okay, what's happening here though? So let's look at one point on the triangle because it's happening for every point of the triangle. Okay, and it's moving 1, 2, 3, 4, 5, 6, 7, 8 to the left, and then 1, 2, 3, 4, 5, 6 up. Okay, so that point C moves 8 to the left and 6 up. Okay, B then also does the same. So 1, 2, 3, 4, 5, 6 up, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 across, okay? It has to because the triangle is the same shape still. So if one point moves by such amount, every other point must move by such amount. Okay, and we have something called a column vector where we can write that nicely. Okay, what this basically means is how much has it moved in the x, how much has it moved in the y. Okay, and we know that going to the left in the x is actually -8, okay, and going up in y is +6. So this is our translation vector that goes ABC to A dash, B dash, C dash. Okay, next one. We have got our rotations, okay? And people always forget one of these three rules when they talk about rotations, okay? So the first thing you need to state is the angle, okay? Students, fine, they get that, perfect, okay? And then you need to say the direction, so is it clockwise, anti-clockwise, okay? Students often kind of get that, but students always forget, okay? You need to also say the center of rotation, okay? And luckily, if you don't know, guess the origin. Okay, guess 0, 0, that's usually where they're rotating from, okay? But it's not necessarily, okay? So you need to know how to figure out all of these three. Okay, angle, all right? How you figure out the angle? Well, if it's gone from this kind of first quadrant to the second quadrant over here, then it's rotated on 90 degrees, okay? What I like to do is I like to put the triangles next to each other pretty much. So imagine if this triangle was up like this, then that's a bit easier to see that it's rotated 90 degrees, okay? They'll often give you nice rotations that you know, right? 90, 180, 270, okay? They won't say, oh, it's rotated, 45 degrees, maybe for a triangle, which would be quite tricky to see that in action. Okay, direction, all right? Is it clockwise? Is it anti-clockwise? Okay, so just clockwise is the way the clock goes. So 1, 3, 6, and anti-clockwise is the other direction. Okay, now our center of rotation. Okay, what I like to do is I like to pick a point. Okay, pick a point on our two triangles. Okay, what the center of rotation is say you had an ant, okay, that was going forward 2, left 2. Okay. It's now been, this ant was first facing this direction. It's now been rotated 90 degrees anti-clockwise, okay? It now faces this direction, okay? But the ant, all it knows to do is to move forward 2 and then left 1. Okay, so that in itself shows it's been a 90-degree rotation, but this also shows this is the center of rotation, okay? Where the ant starts, I guess, is a nice way to think about it. Perfect. Okay, next one, we've got reflections. Okay, so how do we get from shape A to shape B? Okay, well, we reflect on a line, okay? And this line is our y-axis, okay? Draw a mirror down the center, okay? And every point, well, these points on this line are 2 away, so they're 2 away, 2 away, so 2 away, 4 away, so 4 away, etc., etc., etc. Okay, so we've got this nice symmetry. How do we then go A to C? Well, always with reflections, we say we reflect on a line, and that line is y equals x. Okay, maybe the trickier one to see, but we're going across here, and this is 2 right, 1 down away. So we go 1 up, 2 down away, right? If we're going to go 3 down, 2 across, we go 2 down, 3 across. Okay, and we kind of see this nice symmetry that shows that this is reflecting on the line y equals x. Okay, the fourth one, okay, enlargements. All right, for enlargements, we need to say our scale factor, and then we need to say the center of enlargement. Okay, so scale factor, look at a side length. 1, 2, 3. Look at the side length of the other shape. 1, 2, 3, 4, 5, 6. Okay, so if we're going from A to B, the scale factor must be times 2. Okay, because every side length is getting multiplied by 2. Okay, 2 up, 4 up. Okay, so from A to B, we're multiplying it by 2. Okay, so that's scale factor. Center of enlargement, though, is maybe a bit more difficult. Okay, that's why you draw straight lines from a point on one shape to that exact same point on the other shape and go through all the way. Go through all the way, go through all the way, and find the point where those three meet. Okay, that is what we're doing. A bit kind of why we're doing that. Well, compare these points here. You go across one and then up 1, 2, 3, 4, 5, 6. Across one, up 1, 2, 3, 4, 5, 6. Okay, so the amount that B is away from A is always the same that A is away from kind of a center of enlargement. Okay, but the straight lines is definitely the easier method to do. So draw straight lines through the kind of similar points and find out where they meet. Perfect. Okay, I have added this one here. Okay, I know it's cropped out a little bit, just to show that we can enlarge by a scale factor of -3 a center 1, 1. Okay, so which might be a bit weird. All right, weird to see this shape. Don't worry, we'll come to an example. Okay, but don't be afraid of a scale factor of -3. Whenever you have a negative, you're actually rotating this shape 180 degrees. Okay, this shape is actually getting flipped 180 and then it's getting, enlarged by a scale factor of 3. Okay, so just so you've seen something like that. Now that we've seen -3 in action, let's do a example question. Okay, so we've got the scale factor of -2. Okay, so I'm going to do a rough sketch just to give you an idea of what we need to be doing here. Okay, so we're going to plot all our vertices of this triangle. Okay, there we go, and let's connect it up. Perfect, so that's our triangle, and we're enlarging it by a scale factor of -2 at a point 1, 1. So let me represent 1, 1 here. Okay, and we're enlarging it by a scale factor of -2. Okay, so if originally it was 1 away from the center of enlargement, okay, when you enlarge it by a scale factor of -2, okay, it's going to be 2 away in the other direction. Okay, so it's going to be 1, 2 away. All right, so our first point on this scale factored triangle, okay, it's going to be -1, 1. Okay, because it's 2 away from the center of enlargement. Now we can work through using our length enlargement. So this has a length of 2, this has a length of 2, so we're going to have a length of 4 and a length of 4. Okay, so we can have add 4 on here. We can have -5, 1, and then down here. Okay, and this is our enlarged triangle by our -1 scale factor. Okay, and if we do also the lines, you can see these are working. Okay, these are crossing as needed. I find finding one point, right, by finding the point closest to this centre of enlargement and saying, well, our original shape was 1 away, so a scale factor of -2 is going to be -2 away, and then working from there. Okay, now we want to reflect this on the line x is 0. Hopefully we know that the y-axis is the line where x is 0. Okay, so we reflect this over that line and we get a triangle that looks something like this. Okay, right, because it's going 5, 1, and it's going down to 5, -3. Okay, and it's at 1, 1. And that is our final answer.